Third up today, we're thinking about the components of an object's motion. So we're going to imagine that we drop this ball from exactly the height of the desk, and at exactly the same time, this ball rolls off the desk. So imagine you roll this one, and exactly the moment it rolls off, you drop that one. This one is going to follow a path something like that, and that one's going to fall straight down, vertically downwards. If you do this, you will find that the two balls hit the ground at the same time, and that's because the vertical part of their motion is exactly the same. They're moving through the same vertical displacement, and they've got the same vertical acceleration, so they take the same time to fall to the ground. This ball has horizontal motion as well, but horizontal motion is not affected by vertical forces and vertical acceleration, and the other way around, vertical motion is not affected by horizontal forces or horizontal acceleration. The two components of the motion are independent. They don't affect each other. Here's question 3 for today, and I've filled in part A already, so there's the horizontal component and the vertical component. So if you'd like now, pause the video and have a go at part B, which is asking how these change, and then part C, which is asking to explain why. Right then, to see how the horizontal motion changes, we need to know what forces there are in the horizontal direction. And we're told air resistance is negligible. So actually there aren't any forces in the horizontal direction. That means there's no acceleration in the horizontal direction. So this isn't going to change. And so here, horizontal component at B, same as at A. At C, same as at A. At D, same as at A. Explain why, because there are no forces in the horizontal direction. But in the vertical direction, of course, there's gravity, which is acting downwards. So as the ball goes from A to B, the vertical component is going to get smaller and smaller and smaller, and at B it'll be 0. Then it's going to get bigger again, but downwards. So at C it will be downwards and smaller than at A, and then by the time it gets to D it'll be downwards and the same size as at A. And that's because it's accelerating the same amount of time on the way down as it was decelerating on the way up, and it was the same acceleration, so it's perfectly symmetrical. And then for the last 3 marks here, explain what we've just said there.